Yes, anyone. I don't want to call names. This week, yeah, I told you, like we are like half-baked JavaScript developers. Now we are JavaScript developers, just that we are not complete. Until we are done with this particular concept, we are not done. Okay, so I expect some kind of JavaScript magic in you. So just let's talk. I want us to dialogue. Okay. So
Hello.
yeah, what do you think of it? The object-oriented programming, any way you understand it.
Okay. I'm thinking that we for object-oriented programming, it will work. We are going to program or code on how objects behave, or yeah. So that's how I understand object-oriented programming. So according to how objects behave or objects are going to program according to how objects behave.
Okay, that's George's opinion on object-oriented programming, and that's really interesting. Anyone else? I wish everyone talk. Yeah, Ralph.
So object-oriented programming would have to do with as the name says, objects and using objects to create dynamic programs, and also it's a style of programming that has certain principles that it follows, certain principles to make your programs um, more protected from attacks and in a way, and also more dynamic and user friendly. Thank you.
Okay, Ralph also has a fantastic opinion about object-oriented programming. Let's take like two. The ladies, you're not talking at all. At least one of you should talk. So let's take like two more, and then we will proceed. Anyone?
For me, based on the name, I feel like that's what we were doing last week. Um, Targeting the DOM and then manipulating the elements in the objects in the DOM using objects. So that's what I think.
Okay, that's also interesting. Last person. Anyone? Any way you understand?
Um,
Like, Malcolm.
I think it is manipulating your object to behave the way you want it to behave.
Okay. Okay. All right. So I've told you that there is no wrong answer. It depends on how you explain it, and that is very practical when it comes to programming. There is not a wrong answer. It just depends on how you explain and go about it. And so I would say we are all right. We're just going to add some touches to what we just said, and then see what actually object-oriented programming is, and learn how to program using this style. So yeah, I said style because object-oriented programming is a style of programming, and it's centered around the idea of objects. Okay. I decided to draft this down so that later you want to read, you could go through. So it's a programming style. It's not a programming language. So don't confuse object-oriented programming with languages. I remember some time ago I met some people, they were arguing that they were arguing, and then they were comparing object-oriented programming to other languages. Yeah. It's not a language, it's a programming style. So before object-oriented programming was introduced, there was something called procedural programming. Okay, we will go through them one after the other. We will see examples, real-world examples, and then we will look at ways that we can correct that style with object-oriented programming. So don't bother. We'll go through. So before the introduction of object-oriented programming, we had the procedural way of programming. That is where we group variables, like we define variables, a bunch of variables, and initiate them. Some of them we are not going to initiate, and then we call them later in our program. And then we have functions too on one side. So we call the functions when we need them. So it's like variables and functions, and we call them. And most of the time, the functions are interdependent. One function depends on another to work. So that is with the procedural way of programming. Then there comes in the object-oriented way of programming, and you're saying it's a style which is centered around the idea of objects. The objects we are talking about here is just like what we've been learning so far, like last week, objects we learned, and it's centered around it. So I've talked about it. It's not a language, and it's a programming style. And there are so many languages that they've which have adopted this style of programming. Example is C#. We have Java. We have Python. We have Ruby, JavaScript. There are a whole lot more PHP. There are so many languages that they've adopted this style of programming. And that tells you how powerful this style is. And so, as a programmer, you need to know it. And most of the programming, the developer interviews, going for a job interview, at least you ask the question concerning this style of programming. And so it's very important you know how to program with this style, at least have the idea in this style. Then when it comes to development, especially web development, there is something we call framework. Framework is like a blueprint for your program. So I'll give an example. Okay, let me ask, have you ever heard of anything like frameworks in programming? Anyone?
Yeah.
Have you heard of anything? Not just JavaScript.
Yes.
Yeah. Can you?
Hello.
Yeah.
We didn't hear what you said.
Yeah, so let's name some examples of the frameworks you've heard of. Any framework you've heard of?
React.
Technically, React is not a framework, but for now, I'll take it. But it's technically it's not a framework. It's a library. Okay. Yeah.
View.
But for now. Okay, come again.
Node.
Django for Python.
Node is not.
View.
Node is not a framework.
Okay.
View.
Django for. That is with Python, right? Django is with Python.
MongoDB.
View is it's more like React. It's not like it's a library.
What about?
Yeah, you can do better. Let's go.
I have a question. What about jQuery?
So we've mentioned one with Python. Let's go for. So let's look. Come again.
jQuery, is that a framework?
Is it
And please, I want to ask, is MongoDB a framework?
Hold on for me. I can't hear you.
Please, can you hear me?
Please try saying something.
Yeah.
Okay, I think it's better now.
I was asking if MongoDB for database is a framework.
No.
Okay.
Yeah, let's try and add more examples.
I was asking about jQuery.
jQuery is so it falls. It's just like React and Vue.
Okay.
So it's also a library.
How about Angular?
How about Laravel?
Okay. It's a framework. Okay, Laravel for PHP is also a framework.
So, Ruby on Rails.
Ruby on Rails is a language.
And what
I
of
mean,
ES?
Rails, like, yeah, Rails.
Okay.
Hello.
Okay. Let's add
Hello.
the last one.
Bootstrap.
Hello.
Hello.
Yeah. Please, is ASP a framework?
Okay. ASP.NET.
Yes, please.
That's cool. That's on C#, right? Yeah.
Yes, please.
So okay. Then for JavaScript, we are all mentioning and we are not mentioning anything related to JavaScript. So I'll add that for you. So we have Express.js. That's a framework. Okay. When we start with Node, luckily I'll be part of the tutors for Node. We will look at Node. Node is not a framework. It's not a language. So we'll talk about Node later. But when it comes to JavaScript, there is a framework called Express.js. Okay. So these are all frameworks built on languages, and they all adopt this style of programming, that is object-oriented programming. And that tells you how powerful this style is. Okay. So if you want to become a developer or a software engineer or developer, there is no way you would be a complete software developer without knowing this style of programming. Okay. And what makes this programming so important is are these four pillars or concepts. These are the four main concepts of object-oriented programming. Any question up to this point before we move on to the four concepts or pillars of object-oriented programming? Any question? Can we continue?
Yeah.
Okay. So the first one is encapsulation. Encapsulation. Anyone to tell us the meaning, like the English, not technical, just grammar. What's the meaning of encapsulation? You can just do a quick Google search and then tell us encapsulation.
Like to cover something.
Cover.
I think it's like get together, like
To
you know when you say
secure
something,
something in
someone puts something in a
Oh.
capsule. It's like collecting different stuff. So it's like
Okay.
collect, like
Okay.
a collection. Yeah.
Okay, collection. That's interesting.
Or wrap
Anyone-
something into something.
Yeah.
Or
Okay, I would say securing something in something else, like by wrapping. Like that.
okay. So
Like
from what you're saying, that's right. So let's bring it to programming. You remember we've been talking about objects. How can you relate this, like wrapping things together, putting everything together, trying to bring things together? How can you relate this to programming, especially when it comes to objects? How is this related to objects?
Or
I think
gathering.
a div with elements in it.
Okay, that's with HTML. I want in JavaScript.
Okay. An array with elements in them.
An array elements in them. That's okay. Anyone? Last question. That's okay. Okay, let's look at an example. You see, I have this program here, okay? And what this program does is that it calculates the wage for an employee. Okay, so let's call it. I hope you can all see. Please, can you see my screen?
Yes.
Yes.
Okay. So I'll call my function get wage. Then I'll pass my base salary. I'll pass the overtime. Then I'll pass rate to my function. I think I'm not linking it. Hold on for me. Okay.
You haven't console logged to the.
Oh, sorry. Sorry. Okay. So let me bring our friend Zoom. I'll zoom it so we can all see it. Okay. So let's look at this approach. Okay. The way, and we need the base salary. We need overtime, and we need a rate for calculating the wage. And then our get wage function, we have 3 different parameters. We need a base salary, overtime, and a rate. So in order for us to calculate an employee's wage, we need these 3 parameters all the time. And we need to pass them as arguments to the function anytime we want to calculate. Okay, that is with the procedural method. That is the old-fashioned. We have variables on one side, we have functions on one side, and then we call them on another side. And since we started with our studies, we've been using the style a lot. Sometimes we just mix it with the OPP style, but we've been using this a lot of the time. It's normal. Now let's look at the object-oriented way of solving this problem. So we are talking about encapsulation, and you said we are trying to group them. So we can use the concept of objects and group all of, we can restructure it. So let's refactor this using the object-oriented style. So I'll define an object and set it to give me a name for the object.
Salary.
Hello.
Hello,
I
salary.
want the name for our object.
Let's try salary. Hello.
Hello, can you hear me?
Yeah, Betty said salary.
Hello.
Hello, we can
Hello.
hear you. We can hear you.
Okay. So I'm going to declare an object. We are calculating an employee's wage. So I'll call it employee. I'll call the object employee. And our employee has, these are properties of every employee's wage. We need these properties to calculate the wage of the employee. So I will declare them inside of our object. So I'll call base salary, and then I will set it to the 50,000. Then overtime, I'll set it to 10. So we're not doing anything different from what we had. We want to see if you're going to get the same results and see the difference between the two. Let me give it a bit space. Okay. Then we have rates, and the rate is 20. And then we have our function, get wage function here. And if you've not forgotten, we have properties in an object and refer to them as objects, sorry, methods. So we can declare our get wage function here as a method. Okay. And then call it get which function, and it's going to do exactly what this. So return, then we call it this, then okay. So this is our object. This is the object-oriented way. This is the procedural way. Now, in order to get our the wage for this employee, we just need to call the object, which is the employee, and then we call the get wage method on it. Then, so we're going to do the same thing. Let's new wage be equal to this. Then we will log it on the console. Let's call new wage. Okay, so we are getting the same results. Okay, but let's compare this to what we have here. What's the difference between these two styles? Using the procedural way, the procedural method, and then the object-oriented method. Can you spot any difference between the two?
Yeah.
Anyone? Any difference? Yeah.
So with the procedural method, you can call the get wage function. As you can call a function and then give different values into the base salary, the overtime, and the rate. So it's like it's dynamic in a way. If I'm not wrong, that's how I see it. So we can create different instances, yeah, with the procedure method.
Okay. Who else? Any difference you can spot between these two?
I think with the object-oriented method, you group all the employee information into the object. I'll say that's one thing I spot.
Okay.
So all
Last
his
question
roles
then.
are in.
Okay. Last person.
I'll say with the object-oriented, the information we've made in such a way that they are related to each other in one object. That's what I'll say.
Okay. You all have very fantastic observation. Yeah. So the first one, you mentioned that even though this is reusable, we can also make this reusable, and we'll talk about that one too. So here we are calling the function and passing a parameter, the arguments to it. So he says it's reusable. From this example, it's very, very true. But with this same concept, like with this concept, we can make it reusable. But that is not the motive for this encapsulation. That's why I've not talked about it. So what we are saying about encapsulation is that instead of having these variables at one side and this function at one side, grouping them will make our job simpler in a way that encapsulation, so the advantage of this over the procedure is that it reduces complexity. It reduces complexity. What do I mean by that? You know, this is just a simple program, okay? In a real world program, you could end up with so many functions, like this get wage function. You could get so many other functions which are dependent on this. Here we are calculating just the wage. You know, even with the base salary, there are other factors that come into play in order to calculate your base salary. And so we could have another function here, okay, which is also calculating basic salary, if that is the case. Salary. And in order for us to get this base salary, we need to call this function first. Then we will get so something here. So some logic here that will calculate the basic salary. And in order for us to get this, we can just take this one off, come down here and say this. Okay, so this is a step on how I was just talking about. So this is another function as part of this program. So in order for us to get the basic salary, we need to get the factors that come to play that calculates the employee's basic salary before we get the value and then pass it to this get wage function. Now, let's say in future, we want to find another way of calculating the basic salary. When we make change here, so we have just 2 functions. So imagine having like 50 functions just calculating for the basic salary of the wage of an employee. We have to make changes in so many places, so many other functions in order to get our answer right. A small change in one function might cause or might break our program. And that is because we make a change here, because it is related to this function, we need to make another change in this function. So to make that clear, let's say this function takes arguments, some parameters. So let's say skills, years of experience, and for that we need to pass those arguments to here. So I'll say skills on a scale of, I'll just put some values there, and years of experience I'll say 5. So in future, if you want to add another factor to this function which calculates the basic salary, you just pass the argument here and say another factor. So yes, another factor. Once we add the parameter here, we need to pass it to our logic here, and also come up here and then make sure we add that factor here. Okay. So with this approach, we might end up making changes to a whole lot of functions before we get our final answer. And it's very tedious. We might even end up causing our system to malfunction, creating bugs in our system. And that is why this approach is outdated, or I'll call it outdated. Yeah, most people are moving away from this style of programming. Now, with the object-oriented way, we have getWage function here, which takes no parameter. Okay, so anytime we want to make a change, we just need to, if it's the rate, we just need to add it here. So and say another factor. And then if you want to make a change, let's say we want to add it. So we just do an addition and say this dot and then another factor. And then we are done. Anytime we call our getWage function, automatically it will calculate for us using our new factor. And with this, we just have to make changes to only 2 places. Just add it here and then call it in our getWage method. And that makes solves the problem. Yeah.
Please, you are talking very fast.
Okay, I'll slow down. But do you get what the scenario I'm trying to make? Or I should go over again?
Please go over again.
All right. So I was trying to explain the reason I stated here. So I said using encapsulation concept with the OPP method, it helps reduces complexity in our program. And I was trying to make an example out of that so that you'll understand. And what I mean by reducing complexity is that our get wage function, initially we had only one function. Okay, so I'll comment this one out. And then we had, so I'll comment this one also. And then we had base salary as part of our parameters, base salary. This is the original program. Okay, and I said, let's say in future we want to, or this program is a simple one. Let's think of it. Let's add another. Let's step it up a bit and say, before we get this base salary, an amount for the base salary, we need to consider some other factors and calculate the base salary. And so we take in some other factors like skills, years of experience, and other factors in order to calculate the basic salary of that employee. We need these factors before we can get a value, and then this get wage function will calculate the wage for us. Okay, and I said, let's say in the future, we want to add another factor in calculating the basic salary of the employee. Because we've called that this get salary, basic salary function here, anytime we make changes to this function, we need to differentiate it in all the places that we've called this function. So we have another factor here. We need to add this factor to this, and this is just one function. It could be that we've used this function in multiple places. We need to make changes to all those places that we've used this function, and that is complex, it's tedious. We could end up forgetting some of the places that we use this function, and that could create a bug in our program or in our system. We do not want that to happen. So in order to reduce that complexity, we adopt this style of program which is object-oriented. And in this style, what we do is that we just introduce a new property and set our value to it, just like we added a factor here. And then this time, our get wage function is not even taking any parameter. So we don't need to add it here. We just need to call it in the logic here, and automatically to calculate the wage for us. So with the object-oriented method, we just need to make changes to these two places. Whilst in this function or in this approach, we have to make changes to a whole lot of places. And so using the object-oriented programming, it helps reduce complexity in our program.
Hello. The line is breaking out. Oh, it's my side.
His line is breaking.
Grouping related function variables to be here. But did you get the concept I was trying to put out? Hello.
Hello. Hello.
I was asking. Yeah, is the line still breaking?
Yes.
Okay, let's hold on for some time. I'll get back to you very soon. Hello.
Yeah.
Hello.
Hello.
Am I still break?
I don't know. I don't think so for now. Let's see.
Okay. I was asking, even though the line was breaking, but did you get the concept I was trying to explain?
Yes, please.
Okay. So one advantage of encapsulation is that it reduces complexity. The second one is that it increases reusability. So I mentioned that with this particular example, we have just one function here, okay, and that is why we don't see that. So one of you mentioned that this way helps with the reusability, and that is true. But with the object-oriented way, which you will see very shortly, it also increases reusability. Even though this is reusable, but using the object-oriented way is more reusable compared to the procedural method, and we will see that very shortly. But for now, I'll just add it here. It increases reusability. Okay. So that's with encapsulation. With encapsulation, we group related functions and properties into one unit. And that is the whole idea of encapsulation. Anyone with any question regarding encapsulation? That is one of the first concepts under object-oriented programming. It's not related to just JavaScript. It's all languages that adopt this style of programming. So we don't think it's just about JavaScript. We listed some languages here. So all these languages and all these frameworks, they adopt this style and then they use the concept of encapsulation. So that is with. So abstraction. I'll ask again, we'll do the same thing. How do you understand the word abstraction in a general sense? Anyone to help us? Abstraction. Hello?
Hello.
Yeah. I'm asking, yeah, abstraction in a general sense, how do you understand it?
From my dictionary, it says abstraction is the quality of dealing with ideas rather than events, or
Dealing
freedom
with ideas, what?
rather than events. Yes.
Okay. Or
Hello.
hello?
I'll say, in my view, abstraction is the process of maybe removing something. So getting something from another thing.
Okay. Last person.
So I think it's the opposite of the encapsulation we spoke about the first time. Encapsulation.
We'll see whether it's the opposite or trying to remove or trying to, we'll just see. So yeah, abstraction. When we talk of abstract, it's like something that is not in existence, something that we cannot feel or touch, something we cannot see. Okay, and in programming or in object-oriented programming, we adopt this style. You think of a car. How many of us can drive? If you can drive, just say yeah, or some just say hi if you can drive. I want to use an example. I want an example that we can all relate to.
Yeah.
Right.
Not just driving, but have an idea on how you can move a car.
Yeah.
Okay. Adam, Malcolm, Savannah, George, Abiku, Betty. I want to
Oh, what
hear
of
from
tractor?
that. Yeah, it's also a car. Yeah, for now it's a car. Yeah, this example.
Bicycle.
Okay, that's okay. So I think we can go with the example. Now imagine, with a car, when you sit behind the steer or the wheel, the only thing you have at your disposal is the wheel, the gear, and your brakes, and then the accelerator, and then the other one. I think that is the only things you have. The wood. That is not the actual things. Like, they're not the only things coming together to move the car. I don't know if the scenario is clear. There are other complex stuff under the vehicle that will move the car. You just need the wheel, and then the gear, and then the clutch to move the vehicle. But under the hood, there are other stuff like the engine, and then the other stuff that will move the car. Please, do you get the example I'm trying to create here?
Yeah.
I need a response from you, please.
Yes.
Okay. So in that same sense, in programming, sometimes we try to hide the complexity of our program from our consumers. Okay. We can't just expose everything to them. It might even scare them. Think of driving, and then you'll have to control the engine yourself. You look at how the engine functions, you have to control that manually. Aside they're starting the engine, and then things will go on behind the scenes, which you do not know anything about. All you know is that you started the engine. You just need to step on this and move this, and then the car will move. That is, it makes everything so simple for you. You just need few things on the interface, and then you are done. So that is the complexity of the system from the consumer. We are in object so here. I don't think I'm just trying to.
The line is breaking again.
Okay. You have a question? Is it is it better now? I'm still breaking.
Okay, now we can hear you.
Hello.
Hello. Now we can hear you.
Okay. So I was saying that with abstraction, we try to hide the complexities of our objects or our program from our users, and create a simple interface for them to use. So we've talked about methods. So let's.
Okay.
So we try to create a simple interface for our consumers to use. Let's look at this object. So there is an object in our browser called the local storage. And the function of this local storage, it helps us store data in our browser. Okay, so it's a storage in the browser. It's called local storage, and it's an object you can access like this local storage. And then it has these properties. It has a choice. It has length. Okay. Am I still breaking? Is it still breaking?
A bit.
Okay. So if it's okay, kindly let me know. If it's still breaking, you let me know as well. So I was saying that we are trying to bring that concept here. I want to explain with an example, like a real example to you, using the local storage. The local storage is an object in the browser, and its function, it helps you store data in the browser. So let's say in future you are building a system and you want to store the user's authentication details, something like that. It's in the browser that you have to store it because that is where the user is using your system. And so you can save, we have something called token, that is an encrypted security. Okay, like your password and your details, we encrypt them so that someone from somewhere or a hacker cannot get access to your personal details. We can encrypt your details and store it inside this local storage. It's a temporal storage. Once we close the browser, the local storage loses its data. Okay. And another one is the cookie. So the cookie is also an object in a browser. So let's look at the local storage. Since it's an object, it has properties and it has methods. And when we drop or collapse this prototype, we can see so many methods and properties. The F, the last time I explained to you that when you see an F, it means function. So this is a method. And this is how it is called. So we can call the clear method. What this clear, please, am I still breaking or it's okay now?
We can hear you. It's okay.
Okay. So the clear method, it clears the local storage. Okay. This, the get method, the get item, it gets an item from the local storage. So you call the get item method and pass the key or the key to that particular value you want, and it will retrieve it for you. There is a key method in there. There's a length property. Okay. This three dots you see, this length is a getter, and it uses, so it's a computer property. When you see these three dots, it's a computer property. It computes the value from other properties. So you see these three dots, when we click on it, we get 1. So it computes the value and then returns it to us. So it's a getter. The length is a getter, okay. It's also a property on this local storage object. We have remove item. We have set item. We have constructor, which is a storage constructor. We have get length, and you see some of them they are fade out. Some of them have been faded out. Can you see that the difference between these two colors, the set item and constructor?
Yes, we can.
Can you spot the difference between the two? So what I'm trying to explain to you is that not all of the properties are known, like are used outside of this object. You can't just call the local storage and call, so an example, I can call this and it will return this, but we cannot use this outside. We can just, this will just return a property. It's more of like, it's read only. Okay, it's read only, and you cannot use it outside. It is used internally to compute these properties. Another one is this length. When I mentioned the computer property, let me call it again. Okay. I mentioned that this length is a computed property, and it picks values from the property of this object and calculates this. But when we expand this length property, we don't see any function in here. We don't see the functions that go ahead to calculate or compute this property. All we know is that we are getting our value, which is 1. That's the length of the the local storage, and so all the hidden functions that are calculating this, that is what we are saying. It's abstracted from it's abstracted from us. The developers are not letting us see because we don't need them. We don't need to see those ones. So they try to hide those complexities from us and then give access to these simple ones. The clear, we just need a clear. We want to clear, we can clear. If you want the length, we don't need the functions that will compute the property for us. We just need the value. And so we get the value as we want. So they try to hide those properties from us. And as a developer, when you're developing a system using the object-oriented method, you need to make sure that you hide those complexities from your users. Anyone confused with what I just explained? Abstraction. Anyone confused? Are we okay? We've talked about encapsulation. We've talked about abstraction.
So just a clarification. So abstraction is basically, we know that there's like so many complexities, but we're only seeing what like the key factors or components, I would say. I don't know if that's accurate.
So, yes, I wanted to ask a question.
Hello, Isaac.
Hello?
Can anyone else hear me?
I can, but I don't know if he can.
I can hear you.
Did you hear what I asked?
Did you ask a question?
I'm about to, but Calvin just finished. Yes.
No, Savannah, go ahead.
Oh, okay.
Yeah.
I wanted to ask a question about the local storage. It wasn't clear.
Okay. Come again.
So you were okay. I get that the constructor can be used internally only, meaning it's read-only, but aside that, I don't get what you said with the local storage.
Okay. What are you saying? Sabina will answer you.
Okay.
Calvin, did you ask a question? If you did, I did not get it.
Oh, okay. Yeah, the line broke again, so I didn't even hear you mention my name. I was saying, what was I saying? So you said, so basically with abstraction, you said there's so many complexities to the main thing, but we're only seeing like the key points or factors that we would need. I don't know if that makes sense.
Yeah. Exactly.
Is that it?
Yeah. So, so Sabina, what I mentioned was that I was giving an example. So the local storage, and I was saying it has this length property, okay, and this length property, it just doesn't give us. It goes through some processes. It needs to. You remember, sometimes you have to convert to an array, count the items in it, and then return the number of items in the array. That kind of process, the user or the consumer doesn't need to know all those processes. The user doesn't need them. All the user needs is the value, the length. And so we don't put those properties or those methods out for the user. The user is not going to use them. So you hide those details from the user. You can choose to you can choose to give them to the user, but it might be at your own risk, because maybe its role is to compute something for something else. But once the user tries to make changes using those properties or those methods, it's going to affect your whole program. And so you don't need to show it to them. It's something that is inbuilt. So I will go back to the example of the car. You just need to start the engine. What happens in the engine under the bonnet? You don't care. If you try to play with the engine, you might end up breaking the car. So they try to cover it. So you go there, you sit behind the dashboard, you don't see anything, and all you see is your tape and then your wheel. That's all. They cover the rest of the processes. Once you start the engine, how it gets the fuel, how it gets the oil, nobody cares. All cares it has to move. So you have to cover the processes, the internal ones, and then just show the simpler interface, the ones the user will need for the program to work. Just show those details to the user. Sabina, are you okay?
Yes, please. Thank you.
Okay. Please, anyone else with any question? So with abstraction, we are saying it also reduces complexity. It reduces complexity. That's the advantage of abstraction. And the second one that I will add is that it isolates the impact of change. So it isolates the impact of change. Now the user, so I'll go back to the example of the local storage. Okay. So something like the length, all the user knows is that once he types local storage.length, it will return a value. That's all. But once he has no access to the methods that are computing this for, going to have any, he's not going to have access to, he pulls away from the user, and if there is a change, it doesn't have any impact on your system like that. Oosh. So that's what it reduces complexity, it isolates the impact of change. Can we move on to the next one? Inheritance.
Hello, we didn't hear the example you gave under the isolates the impact of change.
So I was saying that since the user does not have access to the complexities of the program or the methods that we use in computing our properties, the user does not have that power to make any change to those ones. You know, I mentioned that when you make them accessible to the user thinking he's doing the right thing, and it might end up breaking the system. But once we hide those complexities from the user and then just show them with what they need, there is no way they are going to create or do something that is going to impact our system that badly.
Okay.
Inheritance. From the general sense, how do we understand the word inheritance? That's the third concept, inheritance.
Willing off something to someone forever.
Okay. Any other?
To pass the attributes of an element to another element.
Okay, so that's wait, okay. Last person, inheritance. So someone said willing the properties to someone, and another is also saying that giving attributes to another. Okay, so what you said, that is exactly what happens here. You remember in one of our projects, that was the card component. An example here. You remember we did this? We created this styles object. Please, do you remember?
Please, have you moved your screen or is the same? Because your screen is stuck.
Yeah, I've opened that project.
Okay, now
Oh,
it's
it's stuck
yeah.
on the.
So
Okay, now.
There's still stuff in there, so
No, it has changed. Maybe the network.
okay.
yeah, what do I see now?
The card
Contact
project.
style, card title. Yeah.
Okay. So I was asking, do you remember we refactored our styles and put them into an object?
Yes.
Yeah. That was inheritance. We were doing that, but we did not know that we were doing that. And what it means is that we create one object, okay, and then we pass that same object to different elements. So here we just have to call our card and call the set style property on it, and then we'll be able to call any of the properties of this object on that particular element. And we have different elements inheriting the properties of this object. We have different objects from here. So here we can call the styles object and then pass its attributes or its properties to this welcome email label. We did the same for this username label. So if you notice, we call this style label style or this label property. We just pass that on to the email label. We pass the same property to this username label, and that was inheritance. Instead of duplicating, you remember when we started with this particular styles, we were duplicating them for each label or for each input. We have to write the styles. But when we adopted this approach, we just have to declare one styles object and pass the properties, and then pass the properties to our elements. And that was inheritance. So when we use this approach or when we adopt this concept, it helps us reduce duplicates in our code. We just don't have to it helps us reduce that redundancy. We have to retype everything over and over again. Also, we can put everything into one unit and then pass the attributes down to the elements or objects that also need that. Any question with inheritance? Any question, please?
No, please.
Okay, so that's with inheritance. And another example that I'm going to demonstrate one for you to see from here. You've been seeing something up down there. The last time I told you I'll talk about it. Console.log. I'm logging the employee object. Okay. Can we all see this prototype?
Yeah.
Can we see this prototype? Yeah.
Yeah.
How many of us know what it does? It's also a property on this object, employee object, but we did not declare anything like that. We've not declared any prototype. But when we log it on the console, we are seeing this prototype property. And it's also an object. How many of us know what it does and where it's coming from? Anyone with any idea?
Can I try?
Yes, please, you can.
I think it's an inbuilt a way of checking the type of variable, maybe something you put in is. So if it was an array, maybe to give an array or something like that.
Okay. Anyone else?
I think it allows it's just from inference, but I would say I think it allows the object to inherit the properties of what like a base object is, like what an object is.
Okay. So you're not wrong. Okay. So Ralph, you're not wrong. So let's look at what we're having here. We have a constructor object. We have another method here. So this is an object, this is a method. We have this method also here. It's prototype of to local string to string, but we did not define anything, any method like that to string on our employee object, but we are having it here. You remember I told you that instead of, there are so many ways of declaring an object. We have the object literal way, and then we have the using the constructor. Please, do you remember?
Yes. Yeah.
So what happens under the hood is that anytime we create an object literal, we create an object using the object literal syntax. JavaScript uses this new object approach to create a new object called employee for us. Okay, anytime we declare an object using the object literal syntax, behind the scenes, JavaScript uses this approach to create an object for us using the name we declared here. So automatically, this object we've created here, even though we did not declare any to string or any other properties, it automatically inherits the properties of this constructor class, this object constructor. Please, is that clear?
Can you come again?
Okay, so I'm saying that we've explained that we can declare an object using the object literal syntax, which we've done here. And I went on to say that the best way for declaring an object is using the object literal syntax, because when you use the object constructor syntax, it's a bit slower compared to the object literal. And we all agreed, that was last week. I'm saying that when we are becoming intermediate developers, so we can explain what happens behind the scenes. That is what I'm trying to do now. I'm saying that when we call this, when we declare an object using the object literal syntax, under the hood, JavaScript tries to hide that complexity from us. That is abstraction. It uses this approach, this new object, it calls the object constructor, to create this object for us. That's why we term the object literal. But under the hood, JavaScript uses this approach to create the object for us. And because it does that, our object literal automatically inherits the properties of this object constructor. And that is why we see the prototype down here. So this prototype are the properties of the object constructor. And our new object employee is inheriting from that object constructor. And that is why we can call to string on our our employee object, and it will still work.
Yeah, that's fine.
Okay. Anyone confused? Anyone? Or we understand? So that's inheritance. You get it from the parents. So it's not magic. When you create this, it goes through this process. But they are adopting the concept of abstraction. So they have can we proceed?
Yes.
Yes, please.
Can we proceed?
Yes.
All right. So here I just would eliminate redundant code. And the example I used was our card component. Instead of redeclaring the styles over and over again, we declare the styles in one object. And then our elements can inherit the properties of that styles object. So it helps us reduce redundancy in our code. That is the reason why we implement this concept of inheritance. The last concept is polymorphism. Poly means many. Okay, let me try and. So poly means many, and then morph means form. So what it means is that many form. Now think of, I'm going to give an example. So I'm going to create a form here. I have a form, text this. Then we have inputs. We can have an input which is type text. Okay. We can have one of type email. We can also have one of type button. Yeah, you can have one like that. We can also have, let me just put something here. Yeah. What polymorphism means is that, you know, this is an input, this is also an input, and this is also an input. This is HTML, it's not a language, and so we can't write logics in here, and that is why we keep on repeating these things. But when it comes to programming languages like JavaScript, and we want to render something like this on our screens, there is no need duplicating. This input has the same form as this input. What I mean by that is that this has an attribute called ID. The input of type email also has the same attribute called ID. The same with the name, type, and even there is another one called value. Okay. You can pass value to this input as well, just as we have this. This also has the attribute type. You see, these inputs, even though they are doing different things, but they have the same form. And so in languages like JavaScript, if we want to render something like this, we don't have to duplicate. We just need to define one function or one method, which will just create these forms, these elements, or these forms. And then we just need to pass in the required properties or the right parameters, and that will create the form for us. So in real world example, like working with frameworks like they call, so they
It's breaking out.
Hello, yeah, break it up.
so I'm trying to create something. We have a function called render. Okay. Render. And what this function render does is that it's not like it's general, but that is the basic idea behind this render. It renders an item on the screen, it renders a form on the screen or an element on the screen. And with that, you don't need to rewrite this thing. All you need to do is to call this render method and pass in the required arguments or parameters, and then it will create that form for you. You don't need to go back creating everything over and over again. And so when you adopt this style, then we are saying that you just need one function which will create that form for you, because it's the same form but with different values. And so you just render it and then pass those values to it, and it will create the form for you. So if you want to define, or if you want to develop or write a code that will do this for us, you can come to JavaScript and then say function and then call it render, which will take these arguments, type or say just ID, and I'll give it name for now. I'll just need this, and then I'll call the document dot create element, and then say input. Okay, so now I have one function which will create these elements for me. Then I can pass in my text, my name, then ID. It will just render it for me. I don't need to go on. So with without this approach, I will just have to come down here and then create this input and then go on and on and on and create multiple inputs. But with the help of this render function, I just need to call this render function once, pass in my argument, and it will render the form for me. And that is what we mean by polymorphism. And so using polymorphism, it helps us refactor our if and else and for loops and our switch cases. So instead of having so many lines of code to do just one thing, we have one simple function which will do that for us. So it helps us refactor our code. That is polymorphism. Any question concerning polymorphism?
Hello.
Okay,
with the example, just
Come
I can go. Okay, so I was asking that with the example you just showed us with the render. The form is going to create just one input form or the three that it's in the HTML.
Structure depending on what you want to do. Okay. So yeah, but for this example in particular, it's creating just one element. Yeah, but you can still go on and declare and design a function which will create depending on. So we can even go ahead and pass an argument like number
Hello.
of hello.
Please, I wanted you to like create the form or inputs on the web page using this example you just gave, the function render.
I'd rather let you do it.
Okay.
The reason why I'll let you do it is that we've done so many projects and some of us have used this concept. That is why when we are done with the assignment or exercise, I want everyone to project. Then we look at different ways of solving that problem. And I've seen so many of you using this approach. Instead of creating it over and over again, you declare a function to do that. So instead of me doing it for you, I'd rather ask you to do it for me. Is that fair?
We take it like that.
Don't take it like that. I want you to understand.
Yeah, understand, no, but like using the functions to create it again, I don't know. I don't know how to go about it. That's why I wanted you to do it for me.
Okay, so you have to try with everything we've learned so far. Just try creating a function called render and use that for rendering your elements and see whether if you've not tried it, then obviously you will not be able to know how to go about it. But once you sit down and you draft, I'll do this, I'll do this, I'll do this, and then you draft that process and you try programming, it will work out for you. So try it, okay?
Okay.
Anyone with any question? We are done with the concept. There are 4. So encapsulation, abstraction, inheritance, and then polymorphism. Any question before I ask my questions? Can we go ahead? Can we proceed, please?
Yes.
All right. So I've left some notes here for you. So when you receive the file, you will have access to this. So don't forget that the best functions are those with no parameters. This is a common concept or idea held by so many developers. The best functions are those without parameters. And the reason why this is true is because of this. Okay, these reasons, the reasons you've stated above here, the concept you just talked about. The less parameters your function have, the less complex it is. Because if you want to come back in future and make changes to it, you just need to make changes to few places in your code. And that is because you have parameters in your functions. So the best functions are those without parameters. and that is why the statement or quote means. And we've talked about this. An object with more than one method has a behavior, just like a person. A person can do so many other things. Okay, a person can talk, a person can walk, a person can eat, a person can jump. And because of that, we say this person has a behavior. And the same way, if our object has more than one method, we say it has behavior. Okay, and that is why I wrote this here. It has behavior. So we are going to look at ways of creating objects. Obviously, in real world program, if we are going object-oriented style, we don't just declare objects like we've done like this and then continue. There are so many ways to declare an object, and depending on the instance and what you want to do, you adopt the right approach. Even though some of them are fading away, or I'll say there are better ways of doing it, and so we don't use them most of the time, but they are still important. And so we go through these 4 ways of creating objects. Okay, so we've talked about this already, using the object literal syntax. So I'll go ahead and then we'll play with that. I'll take this one off. I'll bring back our console. And then log this off. Now let's look at another example. So I'm creating a circle object, and then I'll have radius of 1, and then I'll just put in one method called draw. So for now, I'll just log something on the console. Let's see. Okay, so Adam, let's say I want to draw a circle. Okay, so this is a simple object that will help us draw a circle. But in this implementation, all it will do is that it will just log this on our console for us. So Adam, let's say I want to draw a circle. How do I go about this? What do I do?
To draw a circle.
Yeah.
Is it onto the console or onto the desktop?
So this object, we want to draw a circle. We want to draw a circle.
Okay. So first of all, we'd have to call the function.
Okay.
From the object.
And how do we do that?
So let maybe a circle underscore main be equal to circle dot draw.
Okay. But why do you have to put it inside a variable?
Because it's a function.
It's a function.
You said why do we have to put it? Because we want to call it out of the object, because there are various elements within the object. So we want the specific one and we want to classify it.
What if I do it this way?
Okay.
I hope you are not confused.
No, please.
So we want to draw a circle. We can go with this approach by declaring an object with the object literal syntax, passing our radius, and then our draw method. Okay, so this is with this approach. Then we have the factory approach. Okay. So instead of declaring an object this way, we can come here and then declare another function. This is, so we are talking about the factory functions. Okay. We can declare objects with factories. So what it means is that I can declare this function called, which takes an argument called radius. And what this will do is that it will return the object to us. If you're confused, kindly let me know. And then this will have a radius. Okay. And then it will have a method called draw. And then I'll just copy this and then place it here. Okay. Okay. So this is with our factory approach. Circle has already been. So I'll just comment this one out. Okay. So in this implementation, how do we draw a circle? Yeah, you know, to help us. How do we draw a circle? Covenant. Using the factory or factory functions approach in declaring our, how do we draw a circle?
Okay, so circle and into the bracket the radius.
Set. Okay, so I'll pass 1. That's all.
Let's try that and see.
What would be the output? What do you think we will get?
The output.
Yeah. Yeah, what do you think we are going to get? Anyone to help, Governor?
I'm confused.
I think we should call the circle function a pass output. Come again.
And dot draw to it.
Come again.
Like, can we add dot draw after the 1?
So you are saying we should do this. Should do this.
Yeah.
Yeah. And we are still getting our answer. Okay. But you'll be asking, why do we need to go through this whilst we can do this? Now, let's take a look at this. I'll take this one out for now. And then okay. And then let's log this circle. I'll call circle 1. Okay. What do you see in the console? What do you see in the console?
One draw function.
Yeah. So we have access to the draw method, and then we also have access to the prototype. Okay. What this does is that even though with this we can still get access to by logging the circle. This is more simple compared to this. We're able to reuse this function, this method compared to this one. So when we are working with this, someone mentioned that this approach is reusable compared to what we had down here. And in order to solve that problem of reusability, we can declare our object with the factory function approach, and then we have access to our parameters. Okay, and that is why you choose this approach over this object literal approach. So don't forget, you use this when you know you're going to accept parameters or arguments, then you go with this if they are just static properties. Any question regarding these two approach? The object literal approach.
I understand the
Yeah.
object literal, but not the factory approach. I'm confused.
So with the factory approach, the basic idea behind it is that we are creating a function, and you know a function has the ability to take in arguments or parameters, and not the object literal. We can take arguments with this. Okay. And if you want to make our code reusable, then we need to create a function. And I'm saying with this, if your function is returning an object like this, it is a factory. It's called factory function. So anytime you are thinking of taking arguments into your object, you go with the factory function approach. I don't know if I've answered your question. So let's take questions and then we'll come back to that. Yeah, questions. So it's just a normal function, okay? Just that this time we are returning the object. That is the syntax here. It's a function, but this will be the name of our object. And then we are returning an object, if you could see. We open and close curly brackets, and then do the same thing we do inside here. The same thing. But this time, our object can take in parameters or arguments. And so we call it the same way we call the other one. So we call the draw method on it. And then we have our answer in the console. Can we proceed?
I thought the return works with an if statement, but I don't know, I'm something different. I guess that the return here is
the return works
with an if statement. But I don't know.
Can someone help? When do we use the return keyword?
Return specifies the value that the function would output, or in this case, return. So when you use the return keyword, it's whatever the function would output.
Okay.
So yeah. Okay. Before we continue, let me clarify this. Not all functions return values. Okay. And so in some languages, I don't want to talk about this now, but in some languages, especially the low-level languages, you have to specify the return type of the function. So if it's returning nothing, then we could say void. Okay. When we hover on this right now, okay, this circle, look at what is happening up here. It's a function and it's a circle. Okay. And within this, we have another method, which is draw. And look at the type here. This is the return type of the draw method. It's returning void. Every function returns something, even though we have not specified anything like return here. We've not specified anything like it. Because we've not specified any return here, JavaScript sees that as void, nothing, like you're returning nothing, void. So when we hover on it, now I've changed it to 0, which is a number. So when I hover on this again and I come back, you see here, it has changed to number. That is the return type of our function. So functions, there are two things it could do. One, it computes values. That is, there are some functions, they return void. Nothing. All it has to do is to do some calculation, and that is all. And then the second type of function that we have is that they return values. Okay, so some functions return just values. Others too, they calculate the values. So there's a concept in programming that says a function should be independent of its responsibility or task. If a function is calculating, it should calculate, it shouldn't return a value. And if a function is returning a value, it shouldn't do calculation. Okay, so the return is, it's like, that is what the function is supposed to return after it has completed its task. Let me give you another example, a real world example. Your mother can send you to buy something, okay, or send you. It's either you're going to give something to someone and return nothing to your mom, okay, or you go and get something from someone and bring it back to your mother. You've completed a task, but one of them you're not returning anything, and in programming we say it is void. You're not returning anything. And in such cases, you can ignore this return, like this case, and that is why the type of return is void. But once we are returning a value, like this function, okay, we are returning something which is an object. So this type, the type of this, it's not going to be void. So when we look up here, the return type is an object which contains radius and draw. So don't forget, functions too, it's either returning nothing or a value. Anyone confused, or do you understand what I just explained?
I'm confused.
Why are you
Because
confused?
sometimes when we write functions, we don't bring return, but it still performs the task or the reason why you wrote the function. So
yeah, that is what I was just explaining. Maybe you don't want any value from the function, so you leave it that way. And if you do that, it's returning nothing, void. So automatically it will be added to it for you. In some languages, you have to specify. If you don't specify, it will throw an error. Okay. But in JavaScript, it is not throwing an error because they've handled that for you. If you don't return anything, it sees it as void. You're not returning anything. It will still do what you want it to do. In this case, we are logging. In real-world programs, we will not log, we will return. So let's say we want to return the radius 1 to the user. Instead of logging, we are going to do this. Or we want to return this statement to the user. Okay. Instead of doing console log, we do return. Return. Now, the return type of this function, initially it was void when we were using the console log. Now let's check it. Can you see what's happening here? It's now a string, because that is what we are returning. We are returning a string. In real-world programs, you're not going to console log. You're going to return. So it's either you are returning void or you are returning a value. Does that make sense?
So the return, which is the string, shows in the output plus what the function is supposed to do. Is that it?
I don't get you.
So if you write a function and then you put return something, then maybe return string or return 0 or whatever, does the function run and give you the output wherever you call it, and then it also shows the return 0 in your console again? Or I just don't.
Return doesn't work in a console. Okay, we are using console because we want to see our output. In real-world programs, we don't work with console. You know, let me ask you, before you started web development, did you know there was something called console in your browser?
Please come again. Your line was breaking.
Before you started development, like programming, did you know that there was something called console in your browser, aside
No.
going to Facebook and Twitter? No. Yeah. And so we don't work with console. Console is for development. We want to see the output. In real-world programs, you need to return the value to the user. The user has asked for something. So we go back to our getSwitch function. Okay. This is an example. The user wants to calculate his wage. Once you are done with the calculation, you don't keep the answer in the console. You have to return the answer to the user. either on the screen, anywhere aside the console. Okay. It could be another function waiting for this answer or this value. And so you have to return the value. That is a function returning the value. So in this case, we are returning this base salary. Let's see how we are going to accept it in another function. So I'm going to declare another function here. Okay, and I'll call this net income. Okay. You know, before you can calculate your net income, you need your basic salary. Yeah, you need your basic salary, and then you subtract your expenses. Okay, so maybe your tax and other deductibles from it. Then you get your net income. So if you want to implement that here, well, we need our basic salary. But this function is doing that job for us by calculating our wage for us. That is our wage for us. So we need to call this function, and it's going to return a value. Okay, its return value here. So we need to put that value we are going to receive from that function inside another variable. So we can say, I'll call it salary. Okay. Salary, and I'll call this get wage function. Okay, I'll just close it. Then I need to pass this to it. I'll call from here. So I'll call base salary, and I'll call overtime, and I'll also call rates. Okay. Now let's log this on the console. Let's log for now. Let's see. I told you we are doing this for development. So let's log on the console and see the value we are having for salary. Okay. So I'll call the net income function. Okay. Can you see what I'm seeing on the screen?
Yes.
Where are we getting this value from? We've not inputted any number in this function, but we are getting a number. Where are we getting it from? If you're following.
From the return in the get wage function.
Okay.
Exactly. So this get wage function is returning a value, and we just captured that value and we placed it inside this variable called salary. And because of that, we can do anything we want to do with this. Okay. So we can also do salary minus tax. We don't have any tax variable. Okay. So let's go up here and then declare tax. Tax, mostly it's in percentage, so let's use 0.3. So let's say 30%. Okay, this is an assumption. So I'll come, instead of doing subtraction, I'll do salary. Let's forget about the mass. Okay, I'm just 1. Okay. Sorry. My mouse say hold on for me. So I'm calculating 30% on this. Oh, sorry, I need to do this. So I have the salary here. 30% of the salary. I'm subtracting from this. It's okay. It's okay with the mass. Okay. So salary minus tax. I think we're right. Yeah. So this is our net income. So is it Betty or Savannah?
Betty.
Betty. So now we are getting our salary from the get wage function, and we are doing other manipulations to get our net income with this. So let's say you want to display the net income to your client or your user. You just have to return this, okay? Return this. And you see, it's not in a console anymore because we've not logged it on a console. We are rather returning it. So anywhere in our program that we want to get this value, we can call it. We're going to talk about import and export later, I think along in the course of the week. Then we will learn how to use this and also how to export it. But for now, understand that return is not the same as console.log. Console.log will just put the value here. Return is sending it back to the user. Just the word return. You do something, you return something. Your mother sends you, you have to return something, either void or value. I don't know if I've confused you more or.
So is it like the return is more like you are initiating a variable?
No. Can someone explain to her for me? Can somebody try?
I think the return works like rendering something on the web page, but it happens when the consumer demands for it. If it makes sense.
Anyone else?
I think the return means, okay, end over here. Don't add on to this concept or to this function. So after this function, you can break off over here so that the next one that will come will not join this function.
Okay, who else?
I think one mistake I realized is that some of us are still thinking really in terms of HTML and CSS, but JavaScript is separate from that. Another thing is that you can think of a function like in maths, right? Okay, I can't mention black box, but I'll say like if you have a function in math like addition, right? You have two inputs, maybe 1 and 2. It will return 3. That's what the function does. So you pass 1 and 2 into the addition function. It will do some operation with those inputs. It will do something with those inputs, and then it will return you a value based on what that function does. So if you have an addition like in math, you have 1 and 2. You pass 1 and 2 into the addition function. It will return you a value of 3. Then you can use that 3 for whatever you want. I don't know if that's clear, but that's one way of finding.
Betsy, are you okay or you still need more explanation?
No, I understand.
Are you sure?
Yes, I do.
Some of us are very quiet. Calvin, for instance, Malcolm, and Sabina. Are you all okay?
Some further explanation would help. To be honest, I'm a bit lost.
Further explanation on what?
Everything we just talked about just now, like I got confused, to be very honest.
Okay, so George, can you help explain, like summarize everything we've said? We've talked about the object literal approach and then the factory function approach. Could you please help me with that?
So it's like the factory function approach.
Yeah, George. Kobna.
Yeah.
Hello?
So how did you understand what we talked about, the object literal and the factory function?
Okay, so with but before I explain the factory function. Do you have to explain the function part? Oh,
Can you hear me?
Please, if you can explain everything, even the objects, etc., just everything we just spoke about.
wow. Okay, so with the object literal approach, how I understand it is like how we used to do objects last week, right? So you create your object, then you pass the key and the value. So our first key value is radius with 1, and then the next key value is draw. But then the value for the draw key is a function. And then we are console logging draw circle with radius, and then this dot radius, right? So this dot radius is going to take the value of the radius, which is the 1, and return it to the function. So anytime we call the object by using the circle dot draw, it will pick the radius 1 and put it inside the draw, the function in the draw, and then it will return the console log. Is that okay?
Okay, yeah. I understand the concept you're trying to explain. Okay.
And then with the factory function approach, so we have our function, and then the name of the function is the circle, but then it's taking an input, which is the radius. This time we are not declaring the radius as we did in the object literal. So we are going to take input of the radius, any number at all, and then we'll return an object, which is the radius. So with the object in the return, it's radius, the key is radius, and then the value is radius, which we are going to take from the function, the one in the bracket. And then there's also the draw, and then the value of the draw key is the return draw circle, this dot radius. So we are going to return, when we take the input from the radius, we are going to return that to the draw function. And then when we call the main function itself, it will output the string draw circle with radius. With the radius we input in the parameter. I don't know if that is clear.
Okay, so for the factory function, we had to have had an input. Okay, I think that's what I was.
Yes, that's what he did. The online 62.
Yeah. Okay. And then so whatever we input is what we would return as the function that we is there for the draw function. Yes. Okay. All right. Oh, okay. I think I understand a bit now. Okay. Cool. Sorry, Governor. Thanks.
You're welcome.
So before we move on to constructor, like that will be the last thing we're going to do before we go for break. Then we're going to relax kakra because I think now everything is coming in so fast. So we talk about constructor functions, and then we return to classes. Once we talk about constructor functions, class is something small, okay? And then we can take an exercise to test whether we really have understood what we are doing. So what I will restate is that you can declare an object with the object literal approach. There's nothing wrong with that. But when the need be that you take in arguments or parameters, you can't go with this approach. You need to come down and use a function approach. Declare function, pass in your arguments, and return that object. Create an object. So you remember we are using this, and we said this keyword, the current object. So in this function, this is the function. I hope you know a function is an object, right? Hello?
Yes, please.
Yeah.
Okay, all right, that's good. So if you want to use parameters and arguments, you need to declare a function and then return your object. You can't do that with object literal. That is the main reason why we are doing this. So I just wrote a comment here. We're going to refactor this. Now in ES6, I told you about ES6. That's the ECMAScript. Okay, 2015. There is a new way of handling this. When you're declaring an object and you are setting your properties, and the name of the property is the same as its value, as in, here we have radius. Okay, it's kind of repetition. So once the name we are passing in is the same as the name of our key, you can just delete this. Okay, we can take off the first one and then keep it this way, radius, and it's still going to work that way. And we can log
so I can't hear you.
radius on the screen. Okay, is it better now?
Yeah.
So I'm saying that in ES6 and going forward, we are not going to use this approach again. In ES6, whenever the key and the read have the same name, we can delete one and just delete. Come on. You can just delete this, okay, and then leave one name. So it's still valid. You have property and radius. If you want to confirm, you can just do this radius and then log it on the console to see the value. We have to see one. Okay. 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 Can you please see what's on the screen? Yes, we are getting one, which is the value we pass in here. So it is just a new way of removing those duplicates, those redundant and ugly key value pair. So once the name of the value and then the key are the same, you can keep one, and it will still work. I hope that is clear. This is that clear.
Yeah.
Yes, please.
Good. Then we come down to constructor functions. What do we understand by constructor? General sense, not just programming, constructor.
To build.
Okay, to build. Anyone else? Okay. Do you remember this? Do you remember this?
Yeah.
What name did I call this? What's the name of this string?
The string constructor.
The string constructor. This is what we call a string constructor. And it will create a string for us. Okay. And the last time we said that creating a string or declaring a string with this approach or declaring any of the primitive data types with this approach is less efficient compared to using the literal. Okay. Now, we are going to learn how to do something like this. Declare an object. So they are all objects, and that is why a string is an object. So we can declare an object with a constructor approach. And this is the syntax. It also uses a function, but now the difference is that you make the first letter a capital. So declaring a circle, we give it capital C. So those of us with programming knowledge in other languages. This is what we call a class. I don't know, Ralph, can you relate to this?
Yeah.
Yeah. Anyone with any other programming language background having a function with, yeah. Come again.
Yeah, I know of a class.
Yeah. Which language is that?
Just this JavaScript. So.
Okay. So earlier on, we didn't have any concept like classes in JavaScript. You know, JavaScript was not built for the outside. It was just for browser. It's for the browser. It works in the browser. And there's nothing like classes. The idea of classes wouldn't work in the browser. And so there was no need for classes. But recently, after the introduction of Node.js, then we had something called classes. And that is why we have it in the list here. Okay, some articles will still tell you there's nothing like classes in JavaScript. They are not wrong because initially there wasn't anything like that. And we had to do things this way. If you want to create a class in JavaScript, you have to do it this way. And we were not calling it classes, we called it constructors. Okay, so don't get confused when later on you go back and you read an article and you see there's nothing like classes in JavaScript. Don't get confused. Earlier on, we had constructors and nothing like classes, but now we have something like that. Now we are going to learn that too. If you want to declare a constructor, this is how we go. It's the same as factory functions, but the name of the function must be capital. Okay, the first letter of the name must be capital. So looking at the example I just gave, so if you could remember, we have new string. Okay, we have new number. New object. We had new array. Then we had even with functions, we have something like that. So new function, and that's so we have the function constructor. Okay. And when you do this, it creates an instance for you. Okay. So if you notice, they are all starting with capital letters, and that is why they are called constructors, string constructor. Okay. So when you want to define your custom constructors, you need to follow the convention by starting your function name with a capital letter. That is a constructor. Now let's look at the syntax. It doesn't take this approach. So if we want to declare this property called radius, we need to make use of this keyword. You know, this points to the global object. And Adam, in a browser, what is the global object in a browser?
Global object in a browser.
Yeah.
That is
anyone to
that is maybe the array you call before the function.
Can I try?
Yes, please. Adam, no, Adam, the answer is not right.
Yeah.
Windows.
Come again.
Windows.
It's window, not Windows. So don't get confused, okay?
Okay.
It's window. That is a global object. So let's see something here. Our log dots. You know, we are working in a browser now. Okay. Sorry. So log. Let's see what we get. Can we go see what is happening in the console? Yeah. So we just logged this, but this on its own refers to the global object, which is the window. So when we have circle, this is the circle we are seeing, this function. And we are seeing this function because we just declared it this way, and automatically it is added to the global scope. Okay, and we can access it through the window. Through the window object. So the circle is here. You see the let we've been using. This is it. The let function. It is a method in the window object. We have blur, we have cache. Let me go down and I'll call the local storage. Can you see the local storage object here? The one we just used as an example. It's also an object in the window object. So yeah, it's an object in there, it's a property there. There are so many of them. This net income is the one we define here. So anytime we define a function or we declare a variable, automatically it is added to the global scope, which is the window object, except we specify that we don't want to add it to the global. We will get there, how we can define private functions or variables. Okay, but for now, understand that this refers to the global object, which is the window. So Ralph made mention that now we can use JavaScript not only in browser but outside by the help of Node.js. In Node.js, which you will get there, the global we don't have anything like window in Node.js. So we don't have the concept of document in Node.js, but the global object there is called global. So here, instead of having window or the document, there we have something called global. Okay, we are not talking about Node.js, so we will not talk about it, but it's called global. You can call global dot and you get all the global objects from there. But we are talking about JavaScript in the browser now. So the global object is window. And so anytime you call this, it refers to the global object, which is window. Okay. But inside, we want to point this. Instead of pointing it to the global object window, we want to point it to this object, this function, which is an object. So we just do this dot, and then we give it a radius. Okay. And then we say this is equal to our radius, sorry. Oh, okay, let's use the one. Okay. Okay. This is a constructor with a radius 1. Okay. So we can do this. But let me finish putting everything inside. Then we go on. So don't forget, this is in order to define your properties, you need to use this point this keyword to that particular object, so that this refers to the current object, which is the circle constructor. We have this and then draw, and then we can set it to another function. Okay, and this will also return the same thing. So I'll just. So that is with the constructor. But from the examples I've shown you, how do we call a constructor? So let's say right now we want to call our circle constructor. How do we call it? Calvin. From the examples I've shown, before we started with the constructor, I listed some examples. Let's follow. How do we call a constructor function?
So would it be, so let's say let's circle 1 equals to new circle. I'm trying to do like how you did how you call the string constructor.
Okay, so this is it. We have it here.
Yeah. Not correct.
We have one declared already, so I'll use circle 2. Okay.
Okay.
Okay. So this is how we initiate or invoke our class constructor, just like the way we call string constructor, the number constructor, the array constructor, the object constructor. The same way we can call our circle constructor. Okay, but the difference between this and then the one we have up here is that this is not an object. It has not created an object. It's like a template object.
Hello, you are breaking up.
So,
yeah,
hello.
It's like a what?
Okay, I'm going to, if I'm breaking, let me know. I'm saying that when we do this, we just use the new keyword. Okay, and then we are calling a constructor. When we use the new keyword, it doesn't create a new object for us. The new here doesn't mean it has created, it is an empty object. It doesn't have these properties, it doesn't have this. Okay, so this is like a template. It's just like saying a student constructor. When you create a new student constructor, it is not a student until you start putting the details in there. Okay, so it's a template for creating a circle. So when you do new circle, it creates that template for you, and you can now put in the details. So let's log this on the console and see what I'm talking about. So I'll just call circle 2. Circle 2. Okay. Then okay. The reason why we are having values in here is that we've passed the values to this directly. When I take this one off, okay, you see the radius method is gone. Okay, sorry, the radius property is gone, and that is because here this we are instantiating it, and if you don't want anything like that to happen, we just need to. It's a template we are creating, so we can pass values to it directly.
Not again. Or it's just me.
Okay, let's wait for some time and let's see. Hello, am I still breaking?
No, it's better now.
Okay, so I'll take this. I will just comment this one out. Okay, now I have a radius which is set to nothing. I just pointed this keyword to this current object, and I was saying that when we do this, when we call the circle constructor with the new keyword, it's like creating this constructor is a template for creating circles. It is not a circle. Okay, so we can't say this is an object, rather it's a template for creating that object. And so it is empty for now, it is empty, and we just need to add the values to it or the properties to it. So we can have circle 2 and then dots. And then let's do this and see. 2. Okay. So now we just having the radius in here. Okay, because we just passed it to it. So to clear the confusion, if we use the new keyword to instantiate a constructor, it creates the template for us where we can put in our properties. Okay, let's try adding something that is not in there already. So we'll say diameter like this. Okay, and even though we did not declare it here, we did not add it here, you can see it's now part of our constructor. Oh, sorry, the properties in here. Okay, so this is like creating a template. You can put in the properties you want to put in, even if it's a function. You can just so down here we can do circle 2 and then dots. The function we are using is draw. Okay, then we can set it to a function. Okay, and yeah, we have the draw method in here now. Okay, so this is like creating a new student. So real world example, let's say you're developing a system for students, a system that will manage your, like a school management system, and you want to admit new students. you need to create a constructor for the student. So the student constructor. Anytime a new student comes in, you do this, you create new. So in that case, it will be, so instead of doing circle, let me change it to student, okay, so that it fits our example. So this. So anytime a new student comes in, we call new student and pass the properties of that student to that function. If that student can walk, you can just say walk, okay, and then it will be a method in that student's object. So this, when you use this, this is a template for creating an object. Any question?
Yes, I have a question.
Yeah.
So can we reassign a value to a property after maybe we've given a value to, like we've assigned the template to a value?
Okay. What do you think? What do you think? Like before I answer, what do you think from the scenarios of given?
I'll say no, but I just want to confirm.
Why would you say no?
Because you said it's a template and you can't change a template.
Okay. Anyone with any other opinion? Once, let's say this radius, we've assigned a radius with value 2. Can we change the value of radius maybe here, like after, like circle 2, and then do radius of this? Can we do that? Anyone?
Yeah.
Yes.
Yes,
Why do you,
please.
from the scenarios I've given, why do you think we can change it?
It was just a variable name. Oh,
No. Let me give you another example. So you can see it has changed here, right? So this same concept of students, a student comes in and then the student says, I'm 12 years old. The following year, the student can come and say, I'm not 12 years anymore, I'm 13 years old. You should be able to change it. Okay. I don't know if that example makes sense. What the student coming in to change his or her age.
That makes sense.
Yeah. So don't be confused. These are not constant. They are not fixed. They are not fixed. Depending on the value you pass in. So just pick that.
Okay, I understand that one, but I'm saying, what if you change it like the line 69? What if we give a value to this radius? Can we change it in our new circle or something like that?
So we do this. Are you talking about
Yes.
this? Can you see what's happening in the console?
Okay, it's still 5.
Yeah. So this is, let's say this is the first value we passed, but now we updated it. We are setting it to 5 now. It will update. Okay. When we come from big, we will dive deeper. But I want you to understand this. We will dive deeper into the data types, reference types, and then the primitive types, how they behave. Today we are doing real programming, so you need to backlap. Okay. Okay, it's 12:45. Any question regarding constructors? And then we quickly talk about classes and then we go for break because they are related. I told you earlier on that initially we did not have any concept like classes because we were working in a browser. Now that JavaScript is free and can be used outside the browser, we've introduced the concept of classes and it's built on constructors, function constructors. So when any question? Okay, if there is no question, I'll zoom in a bit for you. Can you see these 3 dots under the student constructor, the name? Please, can you all see? Yeah. I will hover on it and see. And then IntelliSense is saying that this constructor function may be converted to a class declaration. This constructor function may be converted to a class declaration. What this means is that we've defined a constructor. We can write a class which will do the same thing, and it's exactly the same thing with no difference. So don't confuse classes with function constructors. They are the same. Classes are just like polished functions. Okay, they are polished functions, but they are functions. Okay, so I'll try and use this because for you to see what will happen when so I'll fix it, and I'm converting this function to classes. So if you notice, convert function to an EX 2015, that is ES6 class. So classes we introduced classes in EX6. It was recently 2015. Earlier on, it was just functions. So I'll convert this to a class. And this is what we got. In order to define, we are talking about the last one, the fourth way of creating an object. So use the class keyword instead of the function keyword. Okay. The class keyword, the name of your class. This time there's nothing like opening and closing brackets. There's nothing like that in classes. Okay. Removing that is the opening and closing brackets. We introduce something called constructor. Okay. So a constructor is a special function. It's a special method that is used in a class. And once your class will take in arguments, you need to pass a constructor. So it's like a magic function. The moment you call the class, it will call the constructor. It's automatic. Okay. So comparing this to not this one. Let me compare it to this. Yeah. So we created. Sorry, I think it's gone. So I'll do it again. I just type the function. Students. Okay. And then we had this dot radius. Then we said let's do it this way. So for now, let's leave it. Now, I'm getting this error because I'm using the same name for them. That is why I'm getting the error. But understand that what we have from line, let me delete this also, so that we can see. Then I'll zoom out a bit. What we have on line 71 to line 75 is the same as what we have here. Okay. This is a function constructor. This is a JavaScript class. In a class, to define a class, you need to bring out the class keyword, the name of the class, open and close curly brackets, and then you need a constructor method or function in there. And what this will do is that this can take the parameters. Okay, so in functions we pass it here, but in the class we pass it to the constructor. I told you that anytime you call or invoke this class, it will automatically, or create an instance of this class, it will automatically call this constructor function. So I said invoke and I changed it to instance of. The reason why I said that was that, you remember I told you that when you do this, it doesn't create an object. It creates an instance, the template, that is the right statement. It creates an instance of the class or the constructor. So when you call, and the same way we call this student's constructor, that's the same way we call the class. Okay, so I'll comment this one out for now. Okay. And then this will still function. So the student class will still work. So new student, and then it will still function. And if I pass my value to it, that is the radius. So I'll pass 4. Okay. So instead of doing this, let me take this one off. I'll take this one also off. And then I'll set this to be equal to radius. Okay. And we're going to see it in here now. We have a radius of 4. We pass the radius to our class, the instance of our class, and the constructor function automatically picks that up and then to render that for us. Any question concerning classes and factory constructor functions? Any question?
Hello.
Yeah.
I have a question. I
Yes,
didn't
please
understand how you were able to pass the 4 like straight like that. I'm confused because when you said the constructor works, the class works like the constructor, but just that when you call the class, it works as it calls the constructor as well. So I thought maybe you call the class and you call the constructor before maybe you can pass the 4 or something.
Yeah.
But that doesn't make like that.
Yeah, it makes
Wait, I have second question. Wait, before you answer, can a class take multiple constructors?
your second question again.
Can a class take multiple constructors?
Can someone answer here for me, please? Both questions. The first question is, why are we not instantiating a class and then later call the constructor function on it? The second question is, can we have multiple constructors in one class? Can someone help?
With the second one, I'll say no.
Why?
Okay, so with a class, if you create a class, it has to have a one constructor that will build everything for you. So there's no need for you creating another constructor to also build like another thing. The default constructor it has is doing everything. So I don't see the reason why you have to get another constructor to perform another thing. Constructor is just to build something for you. So yeah, basically that's how I understand it. So for me, I don't think it's not necessary for you to have another constructor in a class. Just one.
All right.
Has one job. Yeah.
Okay. Thank you. Anyone with any other answer aside apart from what you just said? Okay. So to make everything clear for you, I'm going to say everything about the class again. Okay. So in defining a class, you need a constructor. The constructor is like a magic function or a magic method in a class. It is unique. You can't have multiple constructors. It's just one, and it's unique. And the reason why we are not calling the constructor method on it again is that the moment you instantiate the class and pass a value to as an argument, automatically it calls the constructor. So the constructor is like the moment you instantiate the class, it moves with the class. The moment you instantiate it, it's called automatically. You don't need to call it. You don't need to invoke it. It is automatic. So this name it's unique. I don't want to say it's a keyword, but it's unique. You can't have multiple constructors. So I can do this and I come down here and I'll say constructor, and then I'll go again and okay. Then can you read the error for me? The error in the console.
Concord syntax error. A class may only have one constructor. Okay.
The class may only have it's unique. You can't have,
Okay.
do you understand?
Yes.
And
so can I say that the class works under the encapsulation? So it covers the constructor. Hello. What did you say? You're breaking up.
Come again with your question.
I said, can I say the class encapsulates like the way you said in class, the constructor? It encapsulates the constructor.
Yeah, it has everything inside.
Okay.
So the class is another, it's like a polished version of the constructor functions.
Okay, so why didn't we go with the same ideology like the first one? with line 73. You stated here this radius is equal to radius. But we said that under the constructor, you're supposed to have, like, you don't have to have redundancy there, so you can just use one. So why do we need to do the same for this one?
This, we are using this because we want to input. So here, I'm using radius. Let me change it. Okay, it doesn't fit the class we've created. So I'll do this and I'll say name. Okay, so a new student is coming in.
Frozen, by the way, so okay, it's up now. It's working.
Okay, so I just refactored the code. I changed from radius to name because we are dealing with students now. So a new student is coming in. Okay, I said this is a template. We create an instance of it and we pass in the properties. So a new student is coming in. If we put a fixed name here, then it's no more a template. It's just fixed for one student. But we need to make it dynamic so that whenever a new student comes in, we pass a new name for that student. So when we create an instance of a class, instead of passing for, let's pass a name. So I'll pass Betty. Okay. And now we have the name here, Betty. I can come down here and create another student. Okay, so this I'll say student 1. Then I'll have student 2. Then I'll call this Sabina. Okay. Okay. Then let's log student 2. So you see, with that same class, just one, we don't have to go over repeating, creating this over and over again. We just need one class and we just create an instance of it and pass the name to it. So we have one student called Betty here, another student called Sabina here. Is that clear?
Yeah, it's clear. Thank you.
Students.
So please, does it mean if I want to create another property, like age, I have to create the class student and another constructor again, or just put comma where the name is comma age?
So I said, if you want to make it dynamic, then you need to pass it here. Okay, so let's say age, and then you just refer to it here and point. Okay. Yeah. So here you see we are having undefined because we've not passed anything to the age constructor.
Okay. So now I have a question, follow-up question on what we just did. So assuming I want to pass on like 5 or maybe 10 properties.
Okay.
I would to list everything in the brackets. That's the argument class, so constructor, name, age, then the rest.
Okay, that's a nice question. So when we come back from break, we look at best practices to make our code cleaner and shorter. You remember, anytime you are working on something like this, that is what I've been telling you. Your code should be clean, should be shorter. It shouldn't have so many words or so many typos. So it could happen that our parameters would move up to the next and even cover the whole screen. So we look at ways that we can help manage that when we come from break. I think now we've taken enough. So we can rest for now, and then when we come back, we'll talk about that. Any other question? Any question? We've talked about object-oriented programming, the difference between that and the program. We've looked at some languages that adopt object-oriented programming, some frameworks built on these languages. We've talked about the 4 pillars of object-oriented programming. We also talked about the 4 ways of creating an talked about object literals, factory functions, constructor functions. We've talked about classes. Any question? Or you're still processing? I processing.
Yes.
So I want you to, even as we think about
Hello, you're breaking up.
when we come. Okay, so let's go for break. When we come back, we'll continue. We're going to work on an exercise. So make sure you understand what. So let's go for a break. We resume our to continue.
Hey, 2-5. Please make it 2-5. Why?
Why 2-5? It's 1.
Because you spent 1 minute of our time and we have to get back.
Come on, you're resuming at 1.
Oh, okay. 2.
The best I can do is 1-1 because when I said okay, it was 1-1. That's the best I can do for you.
And we are processing now too, so it will take up our break.
Don't worry, you'll be fine.
Okay.
You can't do everything. Just time.
Okay. Bye.
Goodbye for now.